In a previous video, I showed how you can use Flask to make APIs in Python. So now in this video, I'm going to be showing you how I go about running my Flask APIs inside of a Docker container. So this is not going to be a tutorial about how to use Docker. This is not going to be a tutorial about how to use Flask, but it will be showing you how to combine the two to test your APIs. The reason why I run my Flask APIs in Docker when I'm doing testing and stuff is one, the application's isolated inside of a container. So any dependencies and things that I install using like pip or something like that don't have to be on the system I'm actually running the API on. And then second is it's easy to replicate across platforms. If I have a Docker image and I want to run that on a container, I can easily, share that container with somebody else, share that image with somebody else, and they could also run the same container. I can run it across all my systems. And then if I choose to deploy the application to some service on the web, more than likely, there will be very little I had to change because I have my application tightly compact inside of a container. So I'm going to walk you through step by step of how basically I'm going to go about creating the Dockerized Flask application, and then we're going to test it. Enough of the chit chat. Let's just get started. All right, so in the video today, I'm going to be using code that I made in the previous video that I made on about Flask and how you can build APIs with it. So again, if you haven't, like I said, I will have linked that video both in the description and as a card in this video. Yeah, so because we're using the Flask API from the previous episode, we don't even have to worry about writing any of the actual code. All we're gonna do today is write a Docker file and then build a Docker image and then run the image inside of a container. And then we're going to test it using Postman. So just make sure you have Postman and Docker previously installed on your machine. If you don't, pause, get all that installed, then come back to this video. I'll leave links to both Postman and the Docker homepage in the description down below. So with that being said, let's go ahead and get started. So first things first, we're going to make a Docker file. So I'm just in the directory with the previous code that I already wrote. So if I go in here and I look at the server file, we can see that it contains routes from that previous video that I have in here. So just some real simple routes, and we're going to test against those in a little bit. And then we also have a mock.json that just contains some of that mock data, and you can see that out on the screen now. So with all that handled, let's just do a vim. Let's just do a Docker file. All right. So the first line in our Docker file is going to be from Python 3.8 dash slim dash buster. So this is going to be our base image. The reason why I'm using Python slim buster is instead of like alpine or something else like that, is I just like this one the best. But any image of Python 3.8 should be just fine. Even the default. We're going to set an environment variable, and this environment variable is going to be Flask _app. And we're going to set it to server.py because that's the name of our server file. And this environment variable is needed by Flask. This is how Flask knows what the entry point for our application is. And now we're going to do a copy, and we're just going to copy that directory into source. Then we're going to do working. We're going to change the working directory to be the source directory. We're going to expose port 5000. So we're going to expose port 5000 as a TCP port. This doesn't actually do anything as far as publishing the port for Docker, but it does tell the container, and it does tell the image that it's expecting for us to publish port 5000. So it's just good practice. And now entry point. Now entry point's important. This is going to be what's actually going to run our application. So we're going to do Python 3.8 because that's what we installed. -m to run as a module. We're going to run the Flask module, and we're going to do --host equals 0.0.0.0. So the reason why I added this additional host, you don't have to, but because I will be running this Docker container on a computer that is not the computer I'm going to be testing from with Postman, you have to, because by default, Flask as a security measure only publishes or only allows connections on localhost by default unless you specify something else. So this just says serve it on the actual host machine itself. So that means anything on my network that can reach that host machine can reach that API. So that should be it. So that's what that means. One more thing we're also going to do, we're going to have to install Flask. So we're going to do we'll do that right up here. So we'll do run pip install Flask. We'll do Python 3.8 -m -install -pip install Flask. So that's just going to actually install Flask in our actual container itself. So now we're going to build the actual Docker image that we're going to be using in our Docker container using the Docker file that we just made. So we're going to do sudo docker build -tag. You don't have to give yours a tag, but I'm going to name my Flask server. And I'm going to do a dot to tell it to use the current directory, to use the Docker file in the current directory. And enter, and we should see it build. All right, after a few moments, it's done building. So now that was successful, we know that our container now exists, and now we can use it. So now we're going to create the container that's actually going to run the image that we just created using our Docker file. So to do this, we're going to do sudo docker run IT for interactive shell, P for the publishing of the port. So we're going to publish port 5000 of the host to port 5000 inside of the container. And then we're going to specify the RM because I want it to remove itself after it is torn down. I just don't want to keep the container around. There's no reason to in this case. Then we're going to do --name. So I'm going to specify the name to be flask-server. And the reason for this is if you don't, Docker will give it a random name. So I'd rather have one that I prefer to see. So if I'm seeing it run, it'll work. And last but not least, we're going to put the name of the actual image we're going to use, and we named our image Flask server. So now if we run this, everything runs successfully. So we should see that the Flask app is being served, and we should see all of these fields in here. So this is really good. So now that our Flask server is up and running in our Docker container, we can go ahead and hop into Postman, and it's going and do some requests and make sure that the API is still working the way we want it to. So I'm going to open up Postman. So I'm inside of Postman, and I went ahead and created a collection that has all of the requests that I have currently in my application. But in case I wanted to see them, I could also just split my terminal here, and I could also edit the actual server file, and I can see all of those routes that I created in the previous episode. But so first things first, let's test this first route, which is all about just getting the JSON data back that was loaded. So if we come over here and click send. Okay, awesome. So I get that data back. We can also see that inside of the container, it shows that this device on my network made a GET request at / and that it was successful, status code 200. And we can also see all that information here in Postman as well, but we can see all of that data. And so now we're going to test another route. So let's do like the get username. So this should take in whatever username and return it in the body as a message. And oh, we see that. So returning user with username Shandon codes. Wow. All right. So that's pretty good. And now let's just try some route that doesn't exist. So we should get the 404 handler, and we do. We get the 404 handler. And so we can see all the requests that were made and as they were called up here in our terminal window. Now, as soon as we're done doing all of our testing with our API, what you could do is, because we use the interactive shell, it will respond to Control-C. So we will use Control-C to quit it. And now look, it's gone. And because we used the remove earlier, it's not going to even keep that image around. So we could keep building it and building it and building it. And we can keep building and running it as we make changes to our API. And this way we're running in this isolated environment because this was a very simple example, right? There wasn't like a whole bunch of complexity to our API or anything like that. But if we had multiple different libraries installed and things like that, those aren't things you really want to install in your core system. So you can kind of have them isolated by throwing all this in a container, allowing a container to do it. And you can use the short-lived nature of containers to just be done with it afterwards and not have to worry about it.
So I hope you all found this video useful. I know it's a little bit shorter than usual, but I just wanted to really quick make a video just showing you how that you can run your Flask applications inside of a Docker container just for isolation and ease of use. So yeah, so give it a shot. If you have any questions, please do ask me down in the comments below. I'll try to help any way I can. If you can, go ahead and subscribe to my YouTube channel, follow me on Twitter, and I'll keep you posted when I'm going to make the next video. All right, until then, catch you guys.